Hi everyone, welcome to our ADAT Biostats series. In today's video, we're going to learn about some really important topics that you might be tested on in the ADAT exam. So we're going to be learning about null hypothesis, alternate hypothesis, and we're going to see how type 1 and type 2 errors result. Now, I know these terms sound crazy and scary, and a lot of students try to memorize them, but it's really easy once you learn them, and you'll be able to answer most of the questions on this topic after this video. So let's get started. So first of all, what is a hypothesis? So a hypothesis is simply a statement that we want to test using the data. Think about it this way. For example, if I have invented a brand new fluoride varnish, I believe my varnish prevents cavities better than the regular varnish. Right? So now this is an idea that I have, and I want to test whether my idea is actually true or is it just something that I believe. That is where hypotheses come in. So there are two types of hypotheses that we're going to study and look into, which is null hypothesis and an alternative hypothesis. So what is a null hypothesis? Whenever researchers perform a study, they always begin with something known as a null hypothesis, which is also written as H0 or H0. The null hypothesis always assumes that there is no difference between your idea and the actual idea. There is no effect between the two, and there is no association between the two. For example, in my previous example that I took, I said I have a new fluoride varnish, which I believe is better than the regular varnish. Now that is my idea. But the null hypothesis is going to say that the new fluoride varnish does not reduce dental caries compared to the standard varnish. AKA, there is no difference between the new and the regular varnish. So basically, the job of the null hypothesis is to maintain a neutral stance or a neutral statement between the new fluoride varnish and the standard regular varnish. So basically, it's a very boring statement, right? It's basically saying nothing is happening. Right? So that's my favorite way to remember it. Null hypothesis equals nothing new. That is my absolute favorite way to remember it. So whenever you see H0, you see, well, nothing new is happening. So both the standard and the new treatment or the varnish or the toothpaste or whatever is being tested, none of them have any difference or effect or association. Now let's look at the alternate hypotheses, which is denoted by the H1. This is basically the opposite. It says that there is a difference, there is an effect, and there is an association between our idea and the actual idea. For example, if you look at the example, it says the new fluoride varnish does reduce dental caries better than the standard varnish. So this is the alternative hypothesis. It's known as alternate because it is a hypothesis which is alternate to the null hypothesis, right? So the easiest way to remember this is that there is something new happening, right? So the null hypothesis says nothing new is happening, whereas the alternate hypothesis says something new is happening. That's it. That's basically it. That's all you need to know about null and alternate hypotheses. So now we perform our studies, right? So before we start our studies, we have our null and our alternate hypotheses ready. And then we perform our study, we collect the data, and after looking at the results, we will see that there are only two possibilities that can take place, right? So either there would be something new, which is happening as in the alternate hypothesis right here, or there is nothing new happening as in the null hypothesis right here, right? So either we will accept the null hypothesis or we will reject the null hypothesis, which is basically accepting the alternate hypothesis, right? So let us see these two outcomes, So looking at this, we have two possible outcomes. The first outcome is to reject the null hypothesis, right? This means, as per our example, we will say the new fluoride varnish reduces dental caries better or worse than the standard varnish, right? Since we were comparing the new fluoride varnish and the standard fluoride varnish, if we reject the null hypothesis, which basically said there is nothing new happening, if we're rejecting that, that means that it is definitely reducing dental caries either better or for the worse, right? It can go either way. So that is one outcome that we can get out of our study. The other possible outcome that we need to also consider is that if our study does not show any difference between our idea and the actual reality, then we need to fail to reject the null hypothesis. And I know it sounds a little tough, like why are we saying it like that? We can just say, accept the null hypothesis, right? But notice how I did not say accept the null hypothesis. Why didn't I say that? Because we never prove the null hypothesis is true. We simply say that we don't have enough evidence to reject it. So the correct phrase is fail to reject the null hypothesis, right? So that is one thing that you need to keep in mind, that we never ever say accept the null hypothesis. That is the wrong terminology. We always say fail to reject the null hypothesis. We always say fail to reject the null hypothesis since we do not have enough evidence to actually completely accept the null hypothesis. All right, so now that we have seen the possible outcomes that a study might have, whether we reject the null hypothesis or fail to reject the null hypothesis, let's move on to another term that you might see on your exam, which is the type 1 error. So let's imagine our study makes a mistake, right? Suppose the new fluoride varnish actually does not work. So if this does not work, in reality, the null hypothesis is actually true, because the null hypothesis said that there is no difference between the standard varnish and the new fluoride varnish, right? So if our study says that there is a difference, then that means that our study is actually making a mistake, because in reality there is no difference between the standard and the new one, but our study says there is. So let's look at this with the help of a very common example, right? So for example, in your house there is a smoke detector and there is no smoke. In reality, there is no smoke in your house, but suddenly the alarm starts ringing. So we can say that this is a false alarm situation, right? And that's exactly what type 1 error is. It is a false alarm. It is saying that there is a positive correlation where in actuality there is no correlation, right? So this is a false positive or a false alarm is when we say a type 1 error has occurred in our study. Right? So that is exactly what you need to know. So for example, in this case, our study says that the varnish works. But in actuality, the varnish does not work because it is equal to the standard fluoride varnish, right? So we basically, in this case, we reject the null hypothesis, and that is what basically a type 1 error is, when we reject the null hypothesis when in actuality the null hypothesis is true. All right, so let's look at alpha, which is another term which is kind of linked to type 1 error, and you're going to see it. And although we're going to cover it in our further videos, it's important to know the correlation between alpha and type 1 error. So, how often are researchers willing to make this mistake? That is what alpha is all about. The probability of making a type 1 error is what alpha is, right? So, alpha is simply the probability of making a type 1 error. Most research studies already set an alpha of 0.05, or you can say 5%, which basically just means that before starting the study, the researchers say, all right, maybe we are not 100% accurate, but we cannot be more than 5% inaccurate as well, because then the study would not mean much. So this means that the researchers are willing to accept a 5% chance of making a type 1 error, or a 5% chance of falsely claiming that there is an effect when there really is not any. So 5% is an okay margin of error to keep when you're starting your study, because no study is 100% accurate, right? But we need to set the limit to how much error in the study do we want. And the less the error, the more effective the study is. So by choosing an alpha of 0.05, we accept a small risk that this incorrect conclusion could happen simply due to a chance, right? Don't worry too much about it. We're going to cover alpha and the p-values in the next video, and it'll all make sense. So now let's flip the story. Suppose the fluoride varnish actually does work, which means the alternative hypothesis is actually true and something new is happening. So the alternative hypothesis in reality is true. That means the new fluoride varnish does reduce dental caries better than the standard varnish. But when we conduct our study says that the null hypothesis is correct, right? Whereas in reality, the null hypothesis is false. Basically, it means that your smoke alarm does not ring even when there is smoke in the house, right? The alarm is silent even when there is smoke in the house. So we actually miss a treatment that actually works. That is called a type 2 error, where we basically point out a false negative, where there is actually some kind of effect that we are seeing, but our study kind of ignores that effect and says, yes, the null hypothesis is true, when in actuality it is false and there is actually some kind of effect. It's basically like when your smoke alarm misses the smoke and remains silent. So basically, type 2 error is a false negative. So let's go back to, now let's look at beta, which is basically linked to type 2 error the same way alpha was linked to type 1 error. So beta is basically the probability of making a type 2 error, just like alpha was the probability of making type 1 error, right? Now here, beta is a little different than alpha in the fact that researchers want the beta to be as low a number as possible. Why? Because if we have fewer type 2 errors, that means we are much less likely to miss a real effect. For example, if a patient is actually diseased and our test says the patient is not diseased, we are missing out on detecting the disease in the patient. That means we are making a type 2 error. If type 2 error is beta, that means we want this value to be really low, because if this value is really low, that means our probability of making a type 2 error is low, which means if it's low, we are less likely to misdiagnosing that disease in the patient and telling a diseased patient that you're healthy, and that is pretty dangerous in a lot of cases, right? Now, along with beta comes power. Power equals 1 minus beta, right? Power tells us how likely a study is to correctly detect a real difference when one truly exists, right? And most clinical studies aim for a power of about 80%. Now, I wouldn't go into too much detail about this here because this is exactly what our next video is going to be about, and I'm going to link that in the description so you can have a look at that as well to understand the topic better. The important thing to know here is how beta, power, and type 2 errors are linked together. Alright, so now let's see if we've understood the concepts clearly. Now pause the video, read the question, and try answering before I explain it. The first question says, researchers are evaluating a new fluoride varnish. In reality, the varnish does not reduce dental caries compared with the standard varnish. However, the study concludes that the new varnish is significantly more effective, right? So we say basically, we need to ask two questions. What is the reality? So in reality, the varnish does not work, right? That means the null hypothesis, or H0, is true, right? But what did our study tell us? Our study told us that the null hypothesis is false, or we can say that it rejected, right? It rejected the null hypothesis, which means that it is a type 1 error. When we reject the null hypothesis, it indicates a type 1 error or a false positive. So the answer to this question is A. The next question says, a study investigates a new desensitizing toothpaste, and the toothpaste actually reduces dentin hypersensitivity. But the researchers conclude that there is no significant difference compared with the control group. Similarly, we're going to answer the question by asking, in reality, the toothpaste does reduce. That means the alternative hypothesis is true, whereas our study says that there is no difference, which means it is basically telling us that the null hypothesis is true. Over here, the study has failed to detect the effect, which means this is a case of false negative or type 2 error. So the answer will be B, type 2 error. This question is about alpha. So the third question says, a clinical trial is designed with an alpha level of 0.01 instead of 0.05. Compared with an alpha level of 0.05, this change will increase the probability of a type 1 error, decrease the probability of a type 1 error, increase the power of the study or increase the probability of type 2 error only. Now, so to answer this question, we need to know that a study has changed its alpha from 0.05 to 0.01, which means it has lowered its alpha, right? So basically, when the alpha goes down, which error becomes less likely? So we know that alpha is basically the type 1 error, right? So if alpha goes down, and since alpha is directly proportional to type 1 error will also be reduced, and hence it will decrease the probability of a type 1 error. The next question says, a study fails to reject the null hypothesis. Which statement is most accurate? And this is one of the questions which ADAT loves to ask, which is interpreting questions, right? So you really don't have to get caught up in the words here, and you need to know the meaning behind all the options to answer the question correctly. So if a study fails to reject the null hypothesis, does that mean the null hypothesis is true? No. So the correct answer is there was insufficient evidence to conclude a significant difference exists, right? This is one of the most commonly tested concepts, right? So we never say that we reject or we accept the null hypothesis. We always say a study fails to reject the null hypothesis. Failing to reject does not mean accepting, and that is something you need to keep in mind. So the answer here will be there is insufficient evidence to conclude a significant difference exists. The last question says, a researcher tests a new mouthwash. The null hypothesis states that the mouthwash is no more effective than the standard mouthwash, but our study concludes that the new mouthwash is superior. If this conclusion is incorrect, right? So here they have mentioned that the conclusion is incorrect. Which of the following must be true? So if the study concludes this, right? And if this is incorrect, this means that the null hypothesis is actually true and our study is not seeing it that way. So if the null hypothesis is true, right, the answer becomes B. And these are some of the questions that will just give you an insight on how to go about answering questions on these topics. So let's finish with one quick summary, and if you remember these 7 bullet points, you will answer most of the questions correctly. These are all the high yield points you need to know. And here's my biggest exam tip. Do not memorize type 1 and 2 errors. Instead, ask yourself 2 questions every time you see the question. Ask yourself, what is the reality and what does my study conclude? These are the 2 questions you need to always ask yourself before beginning the question. So once you compare these 2 answers, identifying the correct error becomes surprisingly easy. If you found this video helpful, don't forget to like, subscribe, and share it with your friends. In the next video, we'll cover p-values and statistical significance, where we'll build directly on what you have learned today. So thank you for watching, and I'll see you in the next one.